Welcome to calculus. You will master complex problems, but forget how to add. On this episode, Stevenson will demonstrate
Now that we know that the definite integral just really means find the area under the curve, whenever we see something to this effect, we know we're actually calculating the area under whatever this curve looks like. So we're going to use our area models and our geometric formulas to do that until we learn more techniques on how to approach non-geometric shapes. So what we're going to do here is sketch this. Now you may not realize this, but this is actually a circle. Here's how I know this. If I square both sides, we end up with a circle centered at the origin with a radius of 2. That's the square root of 4 is 2. So the fact that it's a radical means it's the upper half of the circle. So this fancy integral here really is just asking you for the area of this circle. Well, area is pi r squared. The radius is 2. Now this is the area of the entire circle. So what we need to do is half of the area of the circle with a radius of 2. In this example, they're asking us to evaluate the integral from -2 to +1 of absolute value of x dx. Remember, the definite integral just means we're finding the area under this function with these bounds. So the first thing I want to do is sketch my function. So this is the absolute value function. Now the bounds are from -2 to 1. So this is the area that I want. Notice I'm going to have two different triangles here. So all I have to do is evaluate each area separately and then add them together. Now here's what this looks like as an integral though. That's 1/2 base, the base is going to be 2 units, times the height, which is 2. Now let's do the other one. So 1/2 base times height. So this integral is equal to the sum of these two integrals here. In this problem, we are evaluating the definite integral from -2 to +4 of the quantity 1/2 x plus 3 dx. So again, the definite integral just means we're trying to find the area under this curve over this time interval from -2 to 4. So the first thing we want to do is sketch what our function looks like. Now this is a linear function with a slope of 1/2. I need to know what this number is, and the reason I need to know that is because I need to know how does it compare to my bounds. My interval's from -2 to 4. Is -2 in this space between that x-intercept and the origin, or is it past it? And that matters, because if the area is above the x-axis, it's positive, but the area is below the x-axis, it's negative. And there's situations where we want to make this area negative, or we will change it to positive. We'll explore those situations later. So I need to figure out what the x-intercept is. So I'm just going to set this function equal to 0 and solve. So I can see my x-intercept is -6. So my interval begins at -2 and goes until +4. So I can see that my shape is a trapezoid. Now let's review area of a trapezoid. So remember, your bases are parallel to each other, and the height is the side that's perpendicular to those bases. And this is your formula for area of a trapezoid. It's also important to remember the orientation. So this trapezoid here is actually on its side. So the piece that is not perpendicular to the bases has no measure in this formula. So if you think about it, this trapezoid's on its side. So its height is actually this distance right here, from 4 to -2. That's a total of 6 units. Base 1 and base 2 is whatever the function evaluated at 4 and at -2 is. So if I were to draw a picture now, here's what I have for my trapezoid here. I now have all the pieces, and now I can calculate my area.